Hey physics students, so in our last lesson we talked about work, and we talked about work is the force times the displacement, and the unit for work is the joule. And now we're going to go on and we're going to talk about the next part of our unit here about energy. In this lesson we're going to talk about potential energy, and we're going to learn about two different kinds of potential energy here. We're going to talk about gravitational potential energy, and we're going to talk about elastic potential energy. And we'll learn how to calculate those and do some problems with those. So our target is to be able to calculate how much energy an object has. So let's go ahead and let's take a look at potential energy. Alright, so potential energy, we're going to talk about two different kinds of potential energy. We're going to talk about gravitational potential energy as well as elastic potential energy. But kind of in general, just the concept here, potential energy is energy that an object has because of its position, because of where it is. In the case of gravitational potential energy, it's an object is maybe at some height above the ground, and so has some energy because of being at some height above the ground. In the case of elastic potential energy, maybe think about a stone in a slingshot. It's got some kind of potential energy there. If you release the sling, then it's going to go flying, right? So there's some kind of potential energy there. Kind of in general, when we talk about potential energy, we'll use PE as the variable for potential energy, and the units that we use to measure potential energy, and really any kind of energy or work, we use the unit joules. And joules is of course the capital J, just like we learned in our last lesson. So we have two different kinds of potential energy that we're going to talk about. The first one here, gravitational potential energy. Picture, my object at some height above the ground. It's got some energy associated with that height. And we can calculate fairly easily how much energy it has at that height if I know its mass and its height. Okay? The equation to do so, the potential energy due to gravity, oftentimes we'll use PE with a little subscript G for potential energy from gravity. So the potential energy from gravity is equal to the mass times G times its height, right? So mgh, mass times G times the height. And if you remember, G is the acceleration from gravity. It's 9.81 meters per second squared. Okay. So if you multiply those three terms, you'll see the potential energy from gravity. Well, let's have a look at a problem dealing with gravitational potential energy. It says a box has a mass of 5.8 kilograms. The box is lifted from the garage floor and placed on a shelf. If the box gains 145 joules of potential energy, how high is the shelf? So it's given me the potential energy, the mass, I know G, and it wants me to calculate the height. So we're going to use the equation. Potential energy from gravity is mass times G times the height. It told me the mass was 5.8 kilograms in the problem. I know how much G is. And it told me what the potential energy is. So, PE, gravity, it's at 145 joules. Now all we have to do is we'll take these numbers and we will put them into our equation and then we'll solve it. So, PE from gravity is 145. Mass is 5.8. G is 9.81. And the height we don't know, that's what we're going to find. Let's simplify this a little bit. I can multiply these two numbers right here. So I'm going to grab my calculator. I'll bring down the 145. Multiply 5.8 times 9.81. And there, let's see, with two significant digits, it's 57. And I'm going to bring down that H. And then you can see to solve the equation, all I have to do is divide both sides by 57. So the height is 145 divided by 57. which is, let's see, 2 significant digits here, 2.5. And then a height is going to be measured with the units of meters. So the question said, how high is the shelf? It is 2.5 meters high, which is a reasonable height for a shelf. Okay, the other kind of potential energy we're talking about here is what's called elastic potential energy. It is potential energy that comes from something stretchy or springy being stretched or compressed, right? Think about a rubber band or spring or a bungee cord or something along those lines being stretched or compressed. And that's what we're talking about with elastic potential energy. Again, we use joules as the unit to measure any kind of energy. Any kind of energy or work, we use joules is the units that we use. So elastic potential energy, oftentimes we'll use PE with a little e for elastic potential energy. And then you can calculate the elastic potential energy fairly easily. The formula says that the potential energy is equal to 1/2 times K times X squared. And you're probably about to say, what are these terms in here? What is K and X? What are these things? Let me explain them real quick. Okay. K is something called the spring constant. Okay. For whatever spring or rubber band or bungee cord or whatever you're talking about, there is a number that describes how stretchy or springy it is, right? And we call that the spring constant. It's measured in the units of newtons per meter. And this is a number that I would give you in a problem, right? So I would tell you the spring constant, and you can plug it into the formula. Otherwise, they might give you everything else in the formula and ask you to calculate the spring constant. So, I mean, it should be fairly simple. The other number there, X, is the distance that the spring or the rubber band or whatever has been stretched or compressed. So, you know, if it says it's been stretched 2 meters, then it's 2 meters, right? Yeah, so we can calculate the elastic potential as 1/2 times K times X squared. Don't forget the squared. Very common mistake to forget the squared there. Alright, here is a problem for us to take a look at here. It says determine how much energy a spring with a spring constant of 15 newtons per meter stores if it's stretched by 1.6 meters. So let's go ahead and take a look at this, okay? We know we're going to use our elastic potential energy equation. So the potential energy elastic equals 1/2 K times X squared. Okay. Now what does the problem tell me? The problem tells me that the spring constant, K, is 15 newtons per meter. 15 newtons per meter. And it says that it's stretched, the amount that it's stretched is 1.6 meters. Okay. Now I have all these numbers. I can go ahead and put them into my equation and see how much energy. So I'm trying to find potential energy. Elastic, it's 1/2. That's K, which is 15, times X squared, which is 1.6 squared. So let me grab my calculator and work that out. So the potential energy equals 1/2 times 15 times 1.6 squared. And you know, with 2 significant digits, I get 19. And the units that we use for energy, joules. So my answer there, 19 joules. Alright, so 2 different kinds of potential energy we talked about there. We talked about gravitational potential energy, and we talked about elastic potential energy. We did a couple of problems involving potential energy, and next time we're going to go ahead and talk about kinetic energy. So kinetic energy, energy because of an object's motion. We'll talk about that in the next lesson. So hopefully that helps us to be able to calculate how much energy an object has. So until next time, take it easy.